Okay. Okay, so today we're going to talk about physics and Newton's laws of motion. So we're just going to start off with talking about what they are and then just showing examples of them. So we all have a little handout that we can go through. And so I can tell you a little bit about who Isaac Newton is. So he was from England. He was a very smart guy, and he worked to develop calculus and physics at the same time. So when he was working, he came up with three basic ideas that applied to the physics of most motion, but not like modern physics today. And the ideas have been tested and verified so many times over the years that like all of these laws are now called the three laws of motion from Newton. So Mackenzie, do you want to read the first law for us?
Sure. The first law says that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same direction and speed.
Okay, perfect. So for an example of that, we've got a soccer ball right here. And so if it's staying at rest, like, okay, that's a bad example. So the object's at rest, we're going to use my water bottle. Is it moving at all or anything?
No.
No. So then if we push it though at the same speed, is it just moving at the same speed no matter what?
Yes.
Okay, so that's the first law of motion. So without any outside forces, like the object's just going to stay and never move. So it has to have something act upon it. Sean, do you want to read the next law for us?
Yeah, so the second law states that acceleration of an object produced by a net/total applied force is directly related to the magnitude of the force, the same direction as the force, and inversely related to the mass of the object.
Okay. So from this one, like it's not going to be the most perfect example, but it's the best one that I can have. Sean, can I borrow your water bottle? Awesome. So it's like, say this is heading this way, and we push it like that. What happens with the motion? Like, what does it cause to do?
The second object pushes the first object
Yeah.
with a little force.
Right. And it just makes it go faster, right?
Yeah.
That's pretty much like what it does. That's what the second law is. And then, Mackenzie, will you read us the third law?
Yeah. The third law says that for every action force, there is an equal and opposite reaction.
Awesome. Okay. So I need a volunteer. Who wants to volunteer?
I will.
Okay. So all I need you to do is just come over here and roll your water bottle towards this, and then I'll roll the soccer ball towards it, and we'll see what happens. So ready, set, go. So what's the, like, what is it showing right there?
That they equally hit each other and then they stop.
Yeah, so even though they, like, are different sizes, when I was holding both of them, they weighed, like, pretty much the same. So, like, weight-wise, it was the same. Mass, it's a little different, but it was enough weight and force with each other that they would just cancel it out instead of, like, having a heavier object push the smaller object the opposite way. And so we're going to specifically just go over Newton's third law of motion today during our activity. So what we're going to do is we're going to go to this website, and I don't know how to get there. There's the link right there, so you can just like copy it and log in. So we're going to spend a little bit doing it. It says it takes about 10-12 minutes, so we're just all going to work on it together and then go from there. So while it's loading, I'll just show you guys how to play it. And so the cool thing too is it shows like different facts that we have. So it's like equal and opposite reactions. So Newton's third law is it states that every action has an equal and opposite reaction, and a force is push or pull acting on an object. So that's what we just talked about. And so when we're going to press play, we have to take a quiz before, so we can kind of just go over what we learned. So it'll have a question, and then you just try to answer it, and then you continue. And then the way to do it is you just click it. So you click the mouse, and it'll push it down, and then it'll give him energy to bounce. And you're trying to collect the apples, and then not fall. Like that. And so you get to just try it again. And so if you go through the levels and you get 3 stars, pretty simple, but it's a great way to just figure out, like, talking about laws of motion. So let's play for a bit. If you have any questions, then I can answer it for you. But Well, I'll just spend some time with it and then we'll wrap up and just go over what we went.
Sounds good.
Honestly, can't tell how long it's been. You guys are like way better than I am. That's awesome. Where's the sound? How do I turn that off? Okay.
Oops.
It's taking forever to load.
No, no.
Oh,
I
okay.
just-
So I was like, I've got
Jump
it loaded
into
online
those.
that you could use.
Yeah, I missed an apple and that fell.
You guys, I've fallen every time. It's fine. How are you doing, guys?
Take me
I think you're better at it.
home. Yeah.
Wait, you talking about me?
Yeah.
Are you serious? Oh, dang it. I did it. Okay.
Way to be.
Are you past the first one yet?
No.
Me either.
It's okay. We'll only play for like a couple more minutes and then we'll go from there.
Do you have to get all the apples to pass?
I think so. It's really like, it's hard.
Gotta pass that level.
I keep on skipping the very first apple, like.
It happens. Okay. Finally got it. Oh no. I don't know if you actually, I think you just have to like do what you can.
Yeah, I think you just have to like,
Make it to the end.
yeah.
Yeah. I should have read the instructions more, I'm really sorry.
It's pretty sad because I can't remember to do that.
Have either of you made it past the first level yet?
I did.
Alright.
Because
Barely.
you do have to get all the apples because I'm not passing. I've gotten to the end, but that first apple I can't get.
Oh, dang it. Oh boy. Okay. I'll tell you how many levels there are.
Oh, wow. I got the apple.
Go Sean!
Now let's get to the end. Oh, I jumped too far.
The questions get easier as you go through the levels.
Yeah.
Oh,
I
good.
promise.
What level are you on?
1/3.
Nice.
Number one still. Oh, yeah.
That's right. Just need to see how long it's been. Oh, okay. We've got like probably 3 or 4 more minutes. from there. And when you're playing, like, what are the differences? What happened when you decide to, like, let him jump really far, or when you just decide to control the jumps? So I'm learning that. It's pretty interesting.
What's that?
So when you're doing it, if you just let him jump, like, really far, like, it's cool just to see how much, like, force there is.
Right.
Yeah. I just have to get onto this last block or log.
It's frustrating when you have all the apples and then, like, it won't let you pass because you didn't make it to the last one.
My last apple is on the last log and I can't even get on it.
It's okay. Do you have any questions about the quiz that they give you before the level? Let me know and I can help you answer it.
Keep doing it too hard to get on the last one.
Same.
Oops.
If you're too close to the next log, then you're not doing. It's really hard to do as well.
Yeah. That was pretty good.
Yeah, so there's only 4 levels.
Oh, you figured it out.
Yeah. So you guys are gonna do great.
Third.
Okay. Yeah, so as soon as you guys finish, like, then you'll have taken all the questions and it's gonna be awesome. And then we'll go from there. Doing good. Are you on the last level now? Mackenzie?
No, I'm on the third.
Oh, so you're starting the 3rd.
Yeah.
Gotcha. Way to go. That's awesome.
No.
Did you miss an apple?
I missed the last one, which has the last apple.
Oh no.
Uh,
Awesome. This is the last one. Isn't it?
yeah.
You got this. Maybe.
Oh, look at that.
Nice.
Woo!
Oh.
Yeah.
Maybe
Well, I have
there's
the
5
quiz.
levels. My bad. I don't know how to count, team.
Okay, same.
It's so hard. Okay. How you doing?
This is the last.
Yeah, this is the last one for me too.
Awesome.
And wait, what just happened? Holy.
An apple. Nice.
What was your score?
It was probably the exact same. I'm pretty sure actually. Let's see.
Finish. What's your score?
Oh.
No way.
You guys have the same score?
No, she was better.
I don't know how.
Alright. So if we're gonna bring it back now, what did you guys like? What did you notice or what did you learn from the game?
You put a lot of force on him, he flew.
Yeah.
That's true.
It's crazy. When I was thinking about it and I saw the spring, I was thinking like when you're getting ready to jump. So if you like just kind of stand there and jump, you're not going to get a big jump. But if you like get ready and squat and then you jump up, you jump a lot higher.
Right.
And so that's what I was thinking like with him is like he was getting ready to like squat and take a big jump. And then anything else like about motion or just what you learned?
That if something pushes on something else, they all are equal.
Right. Awesome. Okay, so just to wrap up, we're going to have our little response cards that we've got. And we've just got 2 questions up here. And we're just going to raise them up and answer them and then talk about them. So the first one says that a student is golfing and the golf ball keeps rolling until he stops it with his golf club. So you can use your little handout if you need to, or you can decide which one it is. Awesome, so it is Newton's first law of motion. Sean, why is that the answer?
Because, like, the first law states that an object at rest will stay at rest unless acted upon by a force, so.
Perfect. And so the way that it stops moving is because someone's acting to like stop it with a golf club. And then the next question is a student is trying to push a door open and the door stays closed. So what law is that? Awesome. Kenzie, why is that the third law of motion?
It's because the student is pushing on it and the door is giving it an equal and opposite reaction.
Yeah. Exactly, because it's like, let's see, if I'm pushing on like this wall right here, since the wall's got more mass and it weighs more than me, like it's going to give a lot more force back, so I'm not going to be able to do anything, and like I'm going to be the one moving because of it. So that is all. You guys have any questions about physics and the laws of motion?
No.
Awesome. Okay.